Hello, so today we are going to learn methane rearrangement, one of our important photochemical reaction. This is a rearrangement reaction of 1,4-dienes. Okay, so 1,4-dienes in the sense, I'll just draw this. This is how it looks like. So this is first, second, third, fourth and fifth. So this is 1,4 dienes separated by so this is the 1,4-diene, and on cyclization, on rearrangement, it gives you vinyl cyclopropane. So we'll see how it happens. Now what exactly, why do we call it as dipi? Because there are two pi systems over here. Okay, so you can see there are these two pi systems, and these are separated by a saturated carbon atom. So this is your sp3 hybridized. The third carbon atom that I've written over here is your sp3 hybridized carbon atom. So since two unsaturated system or pi systems are separated by an sp3 or a saturated carbon atom, this rearrangement is called as what? Di-pi methane rearrangement. Okay, so what exactly is this rearrangement? In this case, when it undergoes a photochemical rearrangement, I'll first draw the product. I'll give you some hint also afterwards. So this one of the the double bond, like this is the double, there are two double bonds, so one double bond remains intact, and there is a rearrangement where now we'll see some when we study this uh, mechanism, you will get a more idea, but I'm just writing the product over here. What exactly happens is, so first and second, this double bond remains same, and this third carbon atom which was there over here, this carbon, so we have broken a bond between second and third carbon. So this carbon has rearranged, and now it has formed a bond with the fifth carbon. Okay, so what hints, like when I used to study, what I used to do is I used to number these bonds, and then I used to, you can just look at this. There is a new bond formed between which carbon? Second and fourth carbon atom. So new bond is formed between second and fourth carbon atom. There is a new bond formed between third and fifth carbon atom as well. Okay, and the double bond between first and the second carbon is intact. Okay, and which bond is breaking? Bond breaking. Now, of course, this hint you have to apply depending upon what structure you are looking at. The new bond breaking takes place between second and third carbon. It can be between third and fourth carbon as well, but it depends upon your structure. So we'll first take the mechanism, and then we will see lot of examples. So once you get an idea about the mechanism, sorry. So let's study first mechanism, understand this, and then apply all the hints. So we'll go with the simple system over here. So let's take the same. So this numbering that I'm doing, now it may be applicable to this, but this is a general numbering I'm doing to identify the dipi methane system. Okay, and you can also go with this. When photochemical reaction takes place, radicals are formed. Now these are pi bonds, so radicals will be formed at these places. So at first carbon, second carbon, fourth carbon, fifth carbon. Okay, so this is my first, second, this is my third carbon, this is my fourth, and this is my fifth carbon. Okay, you may have a substituent here. Fine. This is called as biradical. Okay, and what happens exactly over here is, now this radical formation which has taken place over here, so the bond breaks at this place. I told you, no, two and third. So if the bond breaks, there's an electron over here, electron over here. Yes or no? So what happens is, this electron, now just have a look at this. I'm just showing you how it is going to take place. Now imagine this bond is, this electron comes back because this is symmetrical. Now we are not going to look into the stability. So this bond comes over here, this bond breaks, and this electron which is there in this case, this electron, imagine it's coming over here, and as soon as it comes over here, so I will just draw this again. So a new bond is formed. So this bond, this electron which was there, There was an electron over here, no? So this has formed a bond over here. So 2 and 4. So what is left now? What is left? An electron over here, radical at fifth position, 1, 2 bond is double bond, fourth bond, and there is this the bond that broke over here. So there is this third carbon atom with these two substituents and the electron over here. Okay, so I'll repeat again. See this is where the bond breaking is taking place. Okay, 2 and 3, these like because it was a pi system, everywhere there is a formation of electrons, so these two electrons are going back forming the bond directly, and the bond when it breaks over here, there is an electron over here and here. So this electron which was formed after bond breaking has come and joined the fourth carbon. So now there is no bond at 2 and 3. Now these two are left. So as soon as this is there, so you imagine this thing is coming over here and there is a bond formation at this place. So if you want to number this back again, this was my fourth, fifth, and this is the third carbon. So that is why I said there is a bond formation between third and fifth carbon, bond formation between second and fourth carbon, and the bond is breaking between where did the bond break? The bond broke between 2 and 3. So bond is breaking between 2 and 3. So if you remember it this way, when you want to write the example, when in exam when you get when you want to write the answer directly, you can just number it. Now just look at it. Let's you will get a better idea when you have these examples. So now you first have to identify whether it is a dipi system or methane system or not. So this is the double bond over here. This is the double bond over here. This is my bond over here. So what I will do is I will first number it. Okay, this is not the nomenclature numbering. It is just a numbering for the sake of our understanding. Okay, now before going to formation of the product, okay, if we go according to that system that I told you, so the bond is breaking. So breaking, bond breaking takes place between which two carbons? 2 and 3. Okay, bond formation is taking place between 2 and 4 and 3 and 5. So if you quickly go according to this, so what are you going to get? And 1 2 bond remains intact. So this is going to remain intact. 2 and 4 bond formation is taking place. This is fourth carbon, this is fifth carbon, first carbon, second carbon. 2 and 4 and 3 and 5. So 3 and 5. So this is your product. Now why you get this product? So let's see. Now that was just a trick that I told you. Now this was the initial structure, and when biradical formation takes place, it takes place at this place, yes or no? So this is 1, 2, 3, 4 and 5. So here there will be a radical, this and this. Now there are chances that if this breaks, you are going to get this product, okay, 2 and 3. But also there is a chance that the third and fourth may also break. Yes or no? So if third and fourth breaks, you may say that if third and fourth breaks over here, okay, so it could look like this. Yes, so either of these two product is possible because both the sides there are double bonds. Yes or no? But if you look at the stability, if you look at the stability of the radicals or the product, this product gives you a complete benzene ring. So stability is maintained. And here there is no benzene ring. So stability is not maintained. So this is comparatively unstable. So out of these, so whenever in exam also when you get a structure like this where there is a benzene ring and a double bond, always put the cyclopropane ring on the side other than the benzene ring double bond. So benzene ring will remain as it is and you will get the double bond on the other side. Okay. Now let's see few more examples where there is no benzene ring. Okay. So for example, let's go for, I guess this is second structure. Okay. No benzene ring, but a substituent is present. Okay. Now, again the same formula you can apply. 1, 2, 3, 4, 5. So you know that the radical formation is going to take place at these positions. Yes or no? Okay. And if we go according to our system, what did we say? 2 and 4 bond formation, 2 and 4 bond formation. Okay, so if I go like this, so 2 and 4, so 1 2 4 5, and 3 and 5 bond formation, yes or no? So 3 and 5 bond formation, this is my third carbon. 1 2, there is a double bond. 1 2, there is a double bond. Now let's understand why you are getting this structure. Okay, so the thing is, if you look at these two, there is a possibility of this system. Okay, so the bond may break here, or the bond may break at this position also. Yes or no? Let me number it. Fine. So there are two possibilities. If one of the possibility is this, when the bond is breaking between 2 and third carbon atom, the bond is breaking between 2 and third carbon atom. If the bond breaks between 2 and fourth carbon atom, so this is 2 third and this is 2 and fourth, sorry, 3 and fourth, 3 and fourth. Okay, so there is a chance that you may get a product like this as well. Yes or no? Now, if you look at the stabilities, now which one is more stable? So both are possible. Okay. So the reason is which one is more stable. So in this case, this is this one. Let me write here. This one is more stable because of the phenyl ring which is attached. So this radical, this electron which is present over here, it is stabilized by resonance and everything, and that is why this being more stable. The intermediate which will be more stable will be this sorry, not, there's not no electron over here. So the intermediate, this type of intermediate will be more stable, fourth and fifth. Okay, so this intermediate is more stable compared to, wait, let me write down. Ha. So compared to this type of intermediate. Are you understanding this? I hope so. So this is less stable. This is less stable. So if it is less stable, it won't last long and it will quickly form the bond. So it quickly forms this bond, and because this intermediate is more stable, it will last long, and this can rearrange itself, and then you can get a bond over here. Okay, so remember this, whichever is more stable will last longer, and you can get the cyclopropane ring on that side. Or you can also see, when you have this, what you can do here is, whichever is more stable side, your cyclopropane will form on that side. You can remember it this way also. More stable side, the cyclopropane will go on that side. Okay. Let's take few more examples over here. Now, before I write the answer, you people can try this. Okay, so what we will do, we will just check which one is more stable. So you know that there will be the radical over here. We just have to find out the stability of these radicals. Okay, so which one is more stable? Which one is more stable? When there was 1 pH, it was more stable. Now there is 2 pH, so this side will be more stable, this will be less stable. So whichever side is more stable, there you will form the cyclopropane ring. Yes or no? Okay, it's a substituent over here, right? So more stable side, why there is more, why it is more stable? Because of two phenyl rings, so more resonance, and that is why more stable. Are you getting this? Okay, it's that easy, because now see, and you can also do it this way: 1 2 3 4 and 5. Apply the same trick. Whichever side is more stable, that opposite side would break that bond and bring it on the other side. Let's go for one more example. Now this is pretty easy. It's symmetrical, so you can form bond on any side. Sorry, yeah. Okay, let's, I'll give you few more examples. You people now, if you have got an idea about this, you decide the side which is more stable and then you form a cyclopropane ring on that side. Now which side is more stable? And yeah, you can remember the stability of free radicals. Tertiary more stable than primary, then secondary and methyl. Okay. And also if you want, if there is a pH radical, pH ring, pH on the carbon, that radical will be also more stable. So if you remember this stability, now check. Decide which one is more stable. So if you go according to this, now this is tertiary radical. This is also tertiary, but in tertiary also it is having a phenyl ring. So this is more stable compared to this one. Yes or no? So when you want to write the product, what did I say? More stable side, you will form the cyclopropane ring. So break this bond. Just write a double bond, this single bond in between. This is my first carbon, second carbon, third carbon, fourth carbon, fifth carbon. Yes or no? So bond between two, three breaks. And even if you want, no, which if once you decide the stability, you can number it the other way so that two, three wala concept will be intact. Okay, this is how you get the product. Okay, I'll write examples, I'll write answers also, but it's advisable that before I write the product, you people can also, come on, you people think which one will be. Now in this case, yes, I told you, remember benzene ring. Form a product where benzene ring remains intact. And so the other side gets the product. So this is very easy to write. So this will remain as it is. pH, show the bond here. Okay. This is how the rearrangement will take place. Fine. Let's go for um, yeah, one example which is generally asked in, okay, let's go for something like, mm, okay, yeah, now there is an electronegative atom, okay. Remember, if something like this is carbon, so when the radicals will take place, formation will take place, it will be like this. So oxygen free radical is less stable than carbon free radical. So this part is more stable and this one is less stable. So less stable side will remain as a double bond, more stable cyclopropane ring. So this is first carbon, second, third, fourth, fifth. So this with the oxygen will remain as it is. Bond formation between 2 and 4. Bond formation. So this is 1, 2, this is 4, 5, 3 and 5. Bond breaks between 2 and 3. Okay. Let's take one more. Yeah. So see this. Which one is less stable? Less stable. Which one is more stable? This side. Now, if you want, you can number the, now number it in a different ways. If you're going with that concept of 1, 2, 3, 4. Okay. So if you go it like this, so more stable side will get the cyclopropane, right? 2 and 4 bond formation takes place. Hmm? This remains as it is. Yes or no? And the cyclopropane ring is over here. Okay. Yeah, there's a bond. Hmm. One more example. We are going to see some rearrangement in this structure. Now, just for the sake of understanding, no, I'm going to number it. So, since this is symmetrical, any side you can number it. 1, 2, 3. Now, this is not as per related to nomenclature. I'm just numbering it for the sake of our understanding. And you know how we are going to learn it. The new bond is formed between which two carbons? New bond is formed between 2 and fourth carbon. Yes or no? So let's see. So this is like 7, 8, This is my sixth carbon. This is my first carbon. One and two bond remains as it is. And let's write this first. This is fifth carbon. Now this is fourth carbon. New bond is formed between which two carbons? Second and this is my fourth, second and fourth carbon. And 2 and 3 bond is breaking, so we are not going to write anything over here. This is my third carbon over here. Yes or no? This is my third carbon. And a new bond is formed between which two other carbon atoms? 3 and 4. 3 and 5. So this is how you're going to write the structure. Yeah, and there is a bond between 4 and 3. That's the original bond which is present. 4 and 3 bond is already present, no? This is how it looks like. Let's rearrange this. So what we can start with first and second if you want. So first and second carbon. Now my second carbon is attached to which carbon? Fourth carbon. See, my second carbon is attached to fourth and 3, 4 and 5. There is a cyclopropane ring. So let's draw it this way. Okay, so my fourth is attached to fifth. Fifth is attached to which carbon? Sixth carbon. Sixth and one are attached to each other. Sixth is attached to seventh. And this is my third carbon. Third carbon is attached to which carbon? Eighth carbon. Eighth carbon is attached to seventh carbon. And there is a double bond between 7 and 8. So whenever you get these structures where this may not be given, the product will be given directly. In such cases, no, you will have to need to do this type of numbering. Okay, and similar rearrangement structure, no, we will take one more structure. Just look at this. So again, it's kind of similar, but slightly different. So let's see. Wait. Okay, so there is a bond, so kind of like this, and there is a double bond over here. And this, okay, so now what's your dipi methane system? You need two pi systems, no? So my dipi system is 1, 2, this is 3, 4, and 5. Okay, and you know this is less stable, no? This is less stable. We have studied that example. So this side, the cyclopropane ring will be formed over here. So what we will do? We will keep this thing as it is, right? We will keep this whole thing as it is. So let's keep the double bond between the 1 and 2 carbon atom intact, and the bond is breaking between second and third carbon. So this, and one more thing, let's number it further because we need to do this afterwards. So let me number this as 6, 7, and 8. Okay. Okay, now if I'm keeping the double bond between first and second carbon intact, because that will stay as it is, yes or no? Now my bond between, new bond is formed between second and fourth. Fourth is attached to fifth carbon. Cyclopropane ring is between third and fifth, yes or no? And then write down the rest of the structure. Okay, so let's write down. This is ninth. This is ninth carbon. So this is my ninth carbon. This is my sixth carbon. The rest of the structure will remain same. This is my seventh carbon, right? And what else is remaining? Third carbon, this is my 8. Now see, my third carbon has shifted over here to fifth. No, there is a bond formed. This is my third. And there is a bond between third and eighth carbon. That is not breaking. So the bond between third and eighth is still there. This is the bond between third and eighth carbon atom. Now let's rearrange this whole structure. Okay, so how to rearrange? The simplest way to start is with this oxygen, carbon. So first carbon, second carbon. Now my second is attached to which carbon? Fourth. And you know there is a cyclopropane ring. So draw that cyclopropane. Fourth is attached to fifth. Fifth is attached to third. Done. Now uh, let's go for the whole thing. So yeah, wait. Let me just. Hmm. Huh. So this is fourth carbon. Okay. This is my third carbon, because if I would have written there, still more gadbad would have happened. This is my fifth carbon. Now my second carbon is attached to ninth carbon. So let me draw that ninth carbon. Ninth carbon is attached to sixth carbon. So sixth carbon is attached to my fifth carbon, done. Sixth carbon is further attached to seventh carbon. Seventh is attached to eighth, and my eighth is attached to third carbon. So this is how the structure will look like. So in exam, you are going to get this structure, and you will be asked to identify what is the product of this. So you should know that this is a dipi methane system. Okay, so these last two examples I took it deliberately to show such examples. I hope you have